Well, that is embarrassing. I did all of part one without hitting the start stream in YouTube. I hit start stream in OBS, but not YouTube. So I'm just going to quickly summarize what I did. So again, here, let's just go back and read this this puzzle here. I found this extremely easy here. Day 4 camp cleanup. Oh, whoops, I need to actually share my screen. And boom. All right. Space needs to be cleared before the last supplies can be unloaded from the ships. And so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed many of the assignments overlap. Try to quickly find overlaps and reduce duplicated effort. In order to do that, the elves pair up and make one big list of section assignments for each pair. Your puzzle input, for example, here's the list of section assignments. For the first few pairs, it means we've got 2 through 4 and 6 through 8. In the second pair, they each have 2 sections, 2, 3, and 4, 5. 5, 6, and 7. And then they also got 7, but also 8 and 9. This example list uses single-digit section IDs to make it easier to draw. So this is just kind of a visualization of what that looks like. We're trying to find ones where one assignment completely overlaps with another one, like this one and this one. Those are the two that completely overlap. So let me just kind of walk you through what I did, because this was pretty simple. I've done a lot of very similar programming in the past. So I basically just start out with a 0 for how many have completely overlapped. For each line, we're going to split it on the comma, and that gives us the assignment on the left and the right. And then I take each of those assignments, I split it on the hyphen so that we get the 22 and the 65, and then the 22 and the 66. And then I return them min and max. Now it's important here, and this is the thing I stumbled on a little bit here, was I needed to convert these numbers to actual numbers because they were coming in as strings. When I first submitted the answer, I actually had too many, and I'm not sure exactly which edge cases triggered it, but apparently JavaScript does some funky things when you pass it strings and ask for greater than or equal to. So basically what I'm trying to do here, in this giant nasty Boolean expression, is just take the first one and say, is this one less than this one? And that's true. And is this one greater than this one? That is false. So we know that one is not contained completely in the other. But I also have to check the opposite, because otherwise I could get a false answer there. So let's look at one that does overlap. So I say, is this less than this one? Yes. Is this greater than this one? Yes. So that means that this is contained within this. For this one, is this less than this? No. So we have to do the opposite and say, is this less than this? Yes. Is this greater than or equal to this? Yes. That means that this one is completely contained in this one. So it really ends up just being a single Boolean expression. But you have to check 4 different things in order to see if the first one is contained in the second, or vice versa. I don't need the console log anymore, so I just keep track of the ones that do that. And then I just return the final number. So that worked out pretty well. I got my number was 584 for my puzzle input. Now, part 2 makes things a little interesting here. Seems like there's still quite a bit of duplicate work planned. Instead, the ELDS would like to know the number of pairs that overlap at all. In the above example, the first 2 pairs, 2 through 4, 6 through 8, and 2 through 3, 4 through 5 don't overlap, while the remaining 4 pairs do overlap. So in this example, the number of overlapping assignment pairs is 4. How many pairs overlap at all? Well, this actually becomes a lot easier because we can just say, well, let's just copy this into Solve2 first here. So instead of having to worry about both ends of it being inside of it, what we can say is, okay, we've got the min of 1 and the max of 1 being contained within the other, or the min of 1 or the max of 1 being contained within the other. Okay, so basically we want to say if, okay, so the first one's min is less than the second one's min, and the first one's max, no, let's see, think about this, and the first one's max is greater than the second one's min. So instead of saying, basically, instead of saying this is less than this and this is greater than this, I'm saying this is less than this and this is greater than this. That says that the 3 is inside of this range here. And that's all that we need to say that it overlaps at all. But we also need to check the other end because maybe the first one doesn't overlap, but the last one does. So we'll also need to check for this being less than this and this being greater than this. So we just say, or, same thing. We're still going to use zeros, min and max here. Min and max is min. Okay, so then this would be 1's max is above the min, and 1's max is below. So this would be a, no, that's correct, greater than or equal to dot max. I believe that should work. And let's test this out. So we have the same input for part 2, or at least the same example input here, as well as the puzzle input, and 2. And let's rename, I'll copy new file and call this 2 output. Whoops. Okay. Example 2 output text. That gives us 4. So let's test this out. And we got that correct. Let's see if 791 is our answer. That's not the right answer. Your answer is too low. Oh, darn. Darn, darn, darn. Okay, so what did I do wrong? Let's see. If I, whoops. Let's close others. and open this one. Okay. So these min and max still mean the same thing. Let's return to day 4. So this is saying, let's see. So this is an overlap. So 791 is too low. You guessed 791. And I'm just double checking that was solved too. Yep. Okay, so let's double check our logic here. So the min of the first one is less than the min of the second one, and the max of the first one is greater than the min of the second. So we're checking the min on both sides of the second one, and we're checking the entire range of the first one. Or if this min and max, again, the entire range of the first one, contains the max point. That seems right. That seems so right. So what is wrong? It's not another weird JavaScript snafu, is it? Like not having semicolons or parentheses, correct? Completely overlapped. Oh, this would be partially overlapped. Of course, naming things doesn't give you the wrong answer, but can confuse you for sure. All the parse logic should be exactly the same. Oh, wait a minute. Oh, yeah, I can just say partially overlaps. But yeah, none of this is changing. I wonder if I get a different answer. Yeah, 791. I cannot see anything wrong with this. What kind of edge cases could possibly exist here? I mean, I'm not just going whole hog on less than, I'm doing less than or equal to because this is inclusive on both ends. 0, 0, 1, 1. Min, min, max, max. Min, min, max, max. But it's not the right answer? That confuses me greatly. And just to make sure, because sometimes this has happened when nope. Looks like they didn't cancel that day because of messed up stuff. So yeah, it's gotta be my code. I must be messed up somehow. What could possibly be the problem? How many assignment pairs do the ranges overlap? How many pairs? So we're only gonna do one per line, which is a pair. We don't have any negative numbers, right? That would be kind of kooky. Not sure if it ever specified positive per se. Okay, so there's not that. There's not that. There's not that. Okay, so I think I can safely assume there's no negative numbers. There shouldn't be any decimals. Nope. These are all integers. And they look like they're all less than 100. Oh, wait a minute. Hold on. Do they have any that are... Well, that wouldn't even matter though, right? I'm just wondering if they have any where they're out of order. Because that could maybe throw things off the way that I'm thinking about it, right? Let's see. We'll say map. We'll say if plus numbers 0 is greater than plus numbers 1, console log the pair, or just p, I guess, or just numbers, I guess. Okay, so there's none that are out of order, so that's good. I guess I could just do this map. N goes to plus n. That way I wouldn't need to have this here or here. Yeah, still no problems there. So what's the problem? Assignment 0 min. Need to see if I have something I can write on or something. Okay, let's just pull up good old MS Paint and kind of whiteboard this. Okay, so we're saying we've got assignment 1 and assignment 2. Okay, so assignment 1's min is less than assignment 1's min, and assignment 0's max less than assignment 1's min. That's correct. So that one does overlap. Okay. What if we have it in opposite order? So we have one like this and one like this. Okay. So let's this a little bit smaller, scroll down. Okay, let's check this again. So assignment 0's min is less than assignment 0's max. False. So this whole thing is false. Okay, so we move on to this one. Assignment 0's min is less than assignment 1's max, which is true, and assignment 0's max is greater than or equal to assignment 1's max. That is true. The only other possible case is when they come and meet up at a single point, right? But that still should cover it because assignment 0's min less than or equal to this one. That is correct. And the max is less than or equal to, that is also correct. And the or means only one has to be true. So yeah, that's going to be correct every time. If we swap them around, we would get the same thing, right? So let's do that last one here. So we'll have first line is this, second line is this. We have assignment 0.min is less than or equal to, so that's false. So it moves on to the second one. Assignment 0's min is less than or equal to the max, which is true, and assignment 0's max is greater than or equal to this. Yes, absolutely true. So then this does overlap. That's all the cases I can think of. What else could possibly be going on here? Think. Operator precedence isn't going to be a problem because I've grouped them by parentheses. I only have one possible increment per loop. We've made sure these are actually numbers and not strings. It's a very simple problem. Both parts, 50 lines. So what am I missing? What am I missing? Maybe I need to read the puzzle one more time. Seems like there's still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. This doesn't overlap and this doesn't overlap. The remaining 4 pairs do overlap. Symbol section 7, 3 through 7, 6, 4 through 6. How many assignment pairs do the ranges overlap? I mean, it doesn't seem ambiguous in any way. Seems like a pretty cut and clean. What is going on? This example list uses single-digit section IDs to make it easier to draw. Your actual list may contain larger numbers. There's no problem there. Maybe I should just type it in manually instead of pasting it. 791. 791. Oh man. Well, that is thoroughly confusing to me. Subreddit. Looking at day 4. I don't want to see any of the day 5 stuff yet. I'm not doing day 5 yet. I don't want day 5. I want day 4. No. Where's day 4? Day 4. Now this is exactly the same code in DB here. Split comma, split that. Yeah, it's the same. Day 5. Too many day 5s. I want day 4. What the heck? I guess I could. Too many day 5s. Day 4. That's pretty good. This is part 1 though. Part 2. That's pretty cool visualization. L1 less than equal to L2. Right, so that's the second one's min. And right one, so that's the first one's max greater than or equal to. I'm sure that there's something stupid I'm doing. Min. Partial overlap. L2, L2. L1, R1. L1, R1. L2. So that's I think it would be the same, but I guess I could try it this way. So this is saying basically to take the min of number 2 and see if it is less than the min of number 1. And the max of the second one is greater than or equal to the min of the first, 0.min. $933. Okay, so let me just figure out what is actually different about this. Let's compare the two here. Okay, so we're saying that the first line is exactly the same. The first line says is the min of assignment 2 within assignment 1, right? And then the second one is saying, is the max of assignment 2 within assignment 1. At least I think that's what it's saying. See, the min is less than this point, and the max is greater than that same point. Okay, now this one, on the other hand, the same line is exactly the same, right? Or the first line is exactly the same. So this is asking the same question, but this second clause is a little bit different. So this is saying instead, is the min of assignment 1 within assignment 2, right? Because we're doing the min and max there. We're just basically swapping the numbers. Why does that give a different answer? Why does that give a different answer? It's the min of assignment 1 within assignment 2. Okay, I see. I see my problem here. Okay, and I'm going to create another example to prove that I have a problem when I use my code. Okay. So I'm going to say new file, and I'm going to say example 2.2.input.txt, and we're going to take the same input and put it in here, but we're going to add an additional use case. Actually, we're going to reverse all of these use cases. So I'm actually going to paste, and what I'll do is delete the comma, cut, and comma paste here. Whoops, that was not good. Okay, so now we should have the exact same thing but flipped. We should get exactly double the answer of the other one. But I predict that my code will not give me that answer. So so this should be 4. I'm going to copy and paste this here and rename it to example 2. And this should be 8. Because they're the same pairs. We've just reversed the order in which we're comparing them. So if we take a look at this, aha, we were missing one. And the one we are missing here, let's go back to day 4 and take a look at this case here. I was saying, is this inside of this? That's what I was missing in Paint, was not just one that overlaps, but one that is completely contained within the other. So yeah, let's actually make this bigger. I was missing the case where line 1 is like that and line 2 is like that. So I would go through and say, is this less than this? Nope. Okay, what about, is this greater? or, well, actually, no. I would say is this or less than this? And the answer, or sorry, is this less than this? Yes. So is this less than this? No. And I would get not the right response there. We need to check both lines as if they are the prime line here. So let's come back here. Let's fix my code here. Okay, and so I'm going to put a little comment here, said first attempt failed for cases when first assignment is completely contained within second. And this is really what we need, is finding out if the min point is contained within each one line or testing it with the other. And so now we get our correct answer, I believe. We'll see if it is, but I'm feeling pretty good about this. This is 933, and that is correct. All right, a deceivingly simple problem that got me tripped up. And again, sorry for solving the first one before realizing I hadn't started the stream. Hopefully you don't feel too gypped from that experience, and it's been made up by my hubris being pointed out here in part 2. Thanks again for watching, and we'll do day 5 tomorrow, same time, same place. See ya.